Okay. Okay. Boys and girls, we're going to talk about Hess's Law. No, it's like I can't do Trump. I can do Colbert doing Trump. The really cool one is when Trevor Noah does Trump. He's like, "It's the best. It's the best you got. This is Hess's Law." Yeah. Trevor Noah does the best Trump. Okay. If you got your products and your reactants, you just subtract your products minus your reactants. That's going to give you your heat of reaction. So if you got negative 560 and negative 240, I think we can agree that that's the most awesome, that is the best, that's the tippy top. You're going to have negative 320, which is going to be exothermic. Okay, does that make sense? So this is what we talked about. So if your energies are given to you, if your products and your reactants are both given to you, you can just subtract. Easy. Okay? We talked about this. So Hess's Law says all the products minus all the reactants. Great. But sometimes you don't have the energy of all the products and all the reactants. You actually have the energies of individual species. Love that movie. Anyway, so take a look at this example. So once again, there's Hess's Law. Calculate the heat of a reaction when 350 grams of methane are burned in excess oxygen. The delta H book values, or internet values, you can use the textbook or use the internet. If you want to use the textbook today, they're in the back corner. It's those blue books over there that say chemistry on them. Those are our textbooks. In case I get hit by a train, a teacher might want to use the textbooks. They're right over there. I like to use my bricks to lift things up. They're good for lifting things up. But anyway, so these are the enthalpy values for individual species. A couple things to mention, first of all, is water as a gas. When water gets released from a chemical reaction like combustion, it comes out as a gas. Okay. And so those are the individual species. How come oxygen is like
Oh, he did the tip.
Yeah, because it's zero. One of the things we need to remember is any element will have an enthalpy value of 0. Right? So oxygen, it's a 0 value. It's 0. There's nothing. Nothing at all. It's like what's going on up here when I'm texting at 3 a.m. It's beautiful. Okay, anyway, so this is our chemical reaction. Now, if we don't have all the products and reactions, we have to use our chemical reaction. This is our chemical reaction. And take a look. Is this balanced? Nope. Okay, go ahead and balance it. It's an extremely easy reaction to balance. Mr. Fisher promises that he's going to let me play with some of his better cameras. So hopefully you can record better if you're taking physics or chemistry.
Yeah, for real, bro. Honestly, I'm not gonna kid.
So again, balance this reaction, balance this very simple exothermic reaction. This is what we did in the back with the hydrogen bubble or the methane bubbles. So they and you light them on fire before they got to the ceiling.
Oh, my grandchildren.
If you think you might have it balanced, give me a thumbs up. All right. So one of the techniques, again, there is balancing on the semester exam. One of the techniques to remember is if you have even numbers over here, you better have even numbers over here. So oxygen is a 2, which means it can only be even numbers, 2, 4, 6, 8. So what's the first thing you want to do over here? Make it even. Make the water an even number of oxygens. So if you don't see it again, oxygen has to be even. So you not be anything but even. So that means you want to make this even, so you always have a multiple of even numbers. So now we got 4 hydrogens. 4 hydrogens. How many oxygens over here? 4. How do we make this 4?
Multiply.
Put a 2. Now we got 4 oxygens. 1 carbon. 1 carbon. Easy peasy, mac and cheesy, and Japanese. Okay. So next. Do not like Japaneses like mac and cheesy? I think I would enjoy mac and cheesy.
Yeah.
Once you have the balanced chemical reaction to write Hess's law is delta H of reaction equals delta H products minus delta H reactants. Right? Hess's law? Products minus reactants?
Yes.
Alright, so what's one of my products?
Products are CO2.
CO2. We've got CO2. And what's my other product?
2H2O.
2H2O. 2H2O. So there's my products. Minus, what's one of my reactants? CH4. And what's my other reactant? 2O2. 2O2. From the all-star in the back. Okay. All right, ladies and gentlemen, if it makes sense to you why this is 1, 2, 1, 2, give me a thumbs up. Good. If you can see why this, Hess's law, can be written like this, give me a thumbs up. If you don't see it, put your hand in the air and wave it around. Okay, for those too timid to mention you have questions, products minus reactants, CO2 is a product, 2H2O is a product, reactants, CH4 is a reactant, 2O2 is a reactant. Now, once you've written it this way, you just plug numbers in. So, CO2 gets negative 394. Water gets 2 times negative 242. Methane gets negative 74.8. And oxygen gets 2 times 0. Oxygen. You're just jealous. You're just jealous of my big brain. Big brain. They all admire my big brain. God bless the United States. Yes. God bless United States. Okay, so go ahead and figure out what this is. Once again, this is a highly exothermic process. So go ahead and bang on your calculator and figure out what it is.
800.
Bang on your calculator.
Easy. Bang outside.
Chevrolet employees. They voted for me, so I gave their employers tax breaks, and he laid them off. I'm sure they'll vote for me again.
Kanye West, 2020.
It's going to be hard for them to vote when they're in Mexico, at the new Chevrolet plant, or in China. But they can vote from China.
Thank you, Kanye. Very cool.
That's all the Kanyes like me. They all love me. No one's done anything more for the Kanye than me. Okay, so what do you got for this highly exothermic process?
Negative 720.4 kilojoules.
Negative 803 kilojoules per mole. Kilojoules per mole of what? Methane. Kilojoules per mole of methane. Because there's a 1 here. If this was a 2 up here, what would you do to this number? You would? Double it. Okay, so there's our enthalpy of reaction. All right, questions? Okay, you are now ready for today's activity.